Hey guys, this video goes along with tasksheet 664. This is on replacing and programming modules. So there's not really a lot that I can do with that here at the house. So we're just gonna kind of talk about my experiences and how we deal with testing and replacing control modules. So to begin, we're gonna with our scenario, we're gonna have a no start condition. If you lose one of the major modules, a lot of times the whole network will go down, and if the whole network's down, the vehicle's just not going to start, because all these modules need to talk to each other to verify all the conditions are right for starting things up. And of course, things like the PCM, the powertrain control module or engine control module, are responsible for things like sending the signal out to hit the starter. So if that module is down, we can't even start the vehicle. So it can really take down the whole car if we have some module problems. So I just want to, before we get started, I just want to say that, I was in the field for 15 years and I've probably replaced 5 to 8 maybe PCMs. So it's not as common as people necessarily think. A lot of times we get people from outside shops. Since I was at the dealer, we get outside shops would tow a vehicle to us, say, hey, we put a PCM in this thing, we just need you guys to program it. So they tow it to us, expect it to get programmed real quick, and then they drive it back home. But 99% of the time, we'd reprogram it and it wouldn't fix the vehicle. So it's not as common as you think. A lot of people kind of get stumped and they think, oh, well, it must be in this magic box that I don't know that much about. But the point is, for all of this, is for you guys to know some things about it so that you don't end up in that situation. So that's just kind of the way it works. But we've got our no start condition. The first thing we want to do is check for codes and see. There's things that we call U codes. Those are always going to be communication codes. So we have, if we look up a code in our PCM and we have a misfire, it's going to start with a P, and that's a powertrain code. Well, anything that starts with a U is going to be a communication code. So we need to scan all our modules and see if we have any communication codes. Say you lose a PCM, you may have communication codes in all of your other modules saying, hey, we can't talk to the PCM. So that kind of points you in the right direction. But if you went with your scan tool and tried to pull codes out of the PCM, it would maybe say that module is not connected or it can't communicate or something. So there's another clue right there that you're in the right spot. So that's what we need to do. We need to, and this is the same thing with most of our other diagnostic strategies. We need to isolate and kind of focus down and find out where our problem is. So we need to isolate which module isn't communicating, and then we can start testing from there. So once we find out that our PCM isn't communicating, we need to basically check all our powers and grounds and communication. So first we're going to isolate. That's what we need to do. And after that, there's 3 things that a module needs. So we need power, ground, communication. That's what a module needs to operate. I mean, there's a little bit more to it, but if you have one that's not functioning properly, not talking to other modules, these are the things you need to look at. So now there are some other things that can happen. I've replaced PCMs for like injector drivers failing inside of them. It'll just have like one fuel injector, it can't turn on for whatever reason. But you can still communicate with it, you can still talk to the module. So this is more if we're not talking to it at all. But power, ground, communication. So when I do power, you pull up a wiring diagram of your PCM. The other thing I like to do is pull up the connector end views, where it just shows all the different pins in the connectors. You want to look through all those diagrams and all those connector end views and look for anything that is power. You want anything that's says, you know, battery positive or ignition feed or anything like that. And there may be 20 different power wires coming to that PCM for various circuits. I'll check all of them. Make sure you're not missing anything at all. So it may take a little bit of digging to get around in there and actually find all of those power wires, but you really need to verify that it has everything that it needs. So after we verify we have all our powers, we need to do the same thing with grounds. We need to be looking at diagrams and connector end views and do the exact same thing with our grounds. So after we've figured out, check all your grounds, maybe use an ohm meter. Make sure you don't have a bunch of resistance on one. Obviously make sure you have continuity from your grounds to your battery. You may need to run some voltage drop tests if you think you have a ground that's maybe suspect. So keep in mind that's another thing you can do is voltage drop tests, if you guys remember that from your basic electrical courses. So after that, we need to look at communication, because we could have this, we could have all our powers and grounds, but if for some reason our communication lines are down for whatever reason, we just can't talk to it. Well, that's going to be kind of the same thing. So we need to verify that we have communication, and that's kind of where the U codes come in. If a bunch of other modules are saying, hey, we can't talk to this thing, you need to check some of those data lines. And you can do it in the same kind of way that you would check your powers and grounds. You can use an ohm meter to ohm out, say, from the PCM to a transmission controller or something. Make sure those high-speed data lines are up. I believe we'll talk a little bit more about this kind of stuff in some of the next units. So if some of these terms aren't really making sense to you, one, either ask me for a little bit more clarification, or we'll get there. So I think some of that stuff's coming up. But we need to check our communication, make sure that all those lines are good. Let's see. So another thing we can do on communication, and I think this is one of the things coming up, we can hook a meter or a scope up to our data lines. They'll produce kind of a waveform also, like you guys saw in the other the videos on the sensors, but they switch high and low. So the sensor in the previous video, those were going 12 volts to 0. A lot of these data lines, they switch from like 2.5 volts to 0, and they switch real fast, and that's basically how they talk to one another. So you can pick that up on a scope, so you can actually verify that there's data trying to come into the PCM. The PCM just isn't listening to it for whatever reason. So after we have checked our communication, so we've got all three of these things that we need to have, we know our module's dead for whatever reason. So after that, we're going to replace our module. So I'm going to talk about what I know specifically in my experience. I haven't reprogrammed modules on any other manufacturers but General Motors, but I have done a lot of modules, or at least a lot of programming on various modules over the years. So there are some things that you kind of need to know, and it's going to be a little bit different based on model and years. That's one thing that changes quite a bit, is how we're going to program stuff. Some of the older ones, you had to take some steps before you replace the modules, even some of the newer ones too. So make sure you're checking service information. For your programming steps. If your module's completely dead, obviously you're not going to be able to pull maybe your old VIN or something out of the old module, but you may need to put in a VIN, especially if you're doing a powertrain control module. Once we get started on our programming procedure, and I'm going to try and find some videos that kind of show this also, some of the steps on how you actually do this stuff. But if you need to enter a VIN, you're going to enter a VIN. Sometimes you'll need to choose choose a specific calibration, so there may be some options. And some of the options may be, if you have, may say, pick this calibration if you have a pickup versus an SUV, or if you have this engine versus that engine. And there's something else in the GM world they call RPO codes. That means regular production options, and that's just options that the vehicle may or may not have. So sometimes you have to go in there and select those things specifically, and you may need to look up specifics about the vehicle to actually find those. But you may have a different calibration in there if you have, say, a 6-speed transmission versus an 8-speed, or if you have this kind of climate system or that kind of climate system. So it just kind of depends, and it's going to be different for pretty much every vehicle. So it's kind of important that you get the right calibrations in there, or things just aren't going to work right. Let's see. One thing to note when we start getting into this, sometimes this takes a little while to program these. It could take a half an hour all said and done, but you're just sitting there with the key on. So the last thing that we ever want to have happen is that the battery goes dead while we're in the middle of programming. So if you can, one of the first things I always do, whether I'm reprogramming or not, when you pull a vehicle in and you got the key on but the engine off, is turn your headlights off. That's going to be a big draw on your battery, and it's pretty unnecessary in the shop. So if you can, turn your headlights off. But we need to maintain our battery voltage. And there's two different ways that we can do this. You can use some sort of battery charger or maintainer, or you can use a jump box. Now, things that need to be said about that. A standard battery charger that you get from a normal store that you probably have in the shop that you may have used before, don't use a regular battery charger. Those things do not put out very clean power. Like, they're fine for charging a battery, but when you're reprogramming and when you're putting data into a module, there's a thing called AC ripple, and it's something that's measurable. You get a little bit of AC voltage, a little bit of noise that comes into the system when we use these battery chargers, and it can mess with your programming. So don't use your just regular old battery charger. Some of them specifically can be used as a power supply, or maybe what we call a battery maintainer, and those give out very clean DC voltage. So if you were to measure it with a meter, it's just a very flat line, just straight DC voltage. If any of you guys have used the Midtronics GR8s that we have up at the school, those have a power supply mode, and those supply clean voltage. So you could use one of those. Midtronics also had a battery maintainer that they pushed out to all the dealerships years ago that specifically used just for maintaining voltage for programming. They won't charge a battery or do any of that kind of thing. They're only meant to keep that voltage up so that we don't die when we're programming this model. Now, I said the other way you could do it is with a jump box. That's the way I always did it, just because I had one. It's not a charger, but it's going to assist. It's going to help keep that battery voltage up. I mean, it's just hooking another battery to the vehicle. So there's no AC ripple or anything in there. It's just going to take a lot longer for the battery and the jump box to drain versus just the battery. So it's a whole lot quicker and easier. You don't have to worry about a bad charger messing up your program. So that's what I would always do if I had a jump box handy. So it's something to keep in mind because it can cause you some problems. So after we've got our battery voltage maintained, we can go ahead with our programming. And it's gonna, once you start it, it's gonna do its thing. It's gonna load in its program, and then it'll probably give you some prompts, maybe make you make some decisions, tell you to turn the ignition on and off, all that kind of stuff. So you kind of have to be around when this stuff is going on. It's not completely automatic, but for the most part, it's going to put in his program and kind of be done. If you are in a dealership setting, it's probably going to give you some sort of warranty claim code that you'll have to put on your repair order just to verify that you actually programmed a module. So I don't know if that's the same for all manufacturers, but we had to do that for every module reprogrammed with GM to get paid for the claim. You had to include that code, and they could actually pull that code up and pull up in a log and see if you actually did it or not, and it'll give them some kind of specifics on it. So they can verify. So after we're done programming, there are sometimes a few more things that need to be done, and sometimes it's just part of the programming process. But one of the biggest things, especially if it's a powertrain or engine control module, is you're probably going to have to relearn the anti-theft system. So it just depends on what kind of system, what the steps are. You may need to relearn the keys. And sometimes some of these systems, if you put a PCM in there, you need to get a hold of the customer and say, you need to bring me every key for this car that you have, and you'll have to relearn all of the keys to the vehicle, or else you'll give the customer their car back. Mom's keys will work fine, and then dad goes to drive it and all his keys don't work and they won't start the vehicle. So you need to make sure you have all of those in your possession if you have to go through some anti-theft. Sometimes you'll need to relearn the key fobs. Sometimes you'll need to relearn the idle. Most of these vehicles now have a learned idle value, so over time they kind of compensate for any kind of crud that builds up in that throttle body. So you may need to go in there and do an idle learn reset. They may not run right until you do that. So in the GM side, there's another thing called crankshaft variation. We were talking about crankshaft position sensors. Well, there can be a little bit of variation in crankshafts, engine to engine, or in your sensors on all your circuits. So GM puts a special function in there called a crankshaft variation relearn. And basically what you do is you get this vehicle hot, and then you go into this special function and command a relearn. It has you race the engine up, just sitting there in neutral as you rev up to about 4,000 RPMs, and it watches for any variation in that crankshaft. It kind of learns that one specifically. So you may need to go and do some sort of variation learn on the crank. But I don't know if other manufacturers do that, but GM's been doing that for a really, really long time. So that's another thing you may have to, or probably will have to do after a PCM replacement. And just while we're talking about it, if you ever replace an engine in a GM vehicle, you'll probably have to do that also after an engine replacement. So some of the real old ones, you may have to do some weird stuff like set up the tire pressure monitor system. You may have to go in and tell it what size tires and what pressure you're running, or the sensors and stuff will be off. But most of that stuff is kind of included in the programming now. So you may not have to go in and tell it tires and pressures, but you'll probably have to go and relearn all the sensors to the module. But that just depends on if that functionality is in the PCM or if that's in a different module. So it just kind of depends. Like I said, all this stuff's going to be different. But after that, really, we just need to clear codes, and then we need to do the thing that we always do every time we do a repair. We need to verify that our repair is correct. So whether that includes a test drive or letting it sit and run in your stalls for a while, checking to make sure your codes that were there before aren't coming back, you always need to verify your repair. So after you verified your repair, you can return your vehicle to the customer. But it sounds kind of complicated, and there are a bunch of moving parts to this, but after you've gone out there and done this a couple of times, it's really not that big of a deal. And a lot of these steps from top to bottom, maybe not the VIN and crank relearn and all that kind of stuff, but all this stuff up here is pretty much going to be the same for any control module. They all need power ground communication, and they're all going to need these same kind of programming steps. They just may have their own unique ones once you get down towards the end, if you have to do any kind of relearns or anything. that's where they're going to be different from one another. But the diagnosis and the programming steps, like I said, are probably going to be the same for pretty much all the modules. It's just the specifics that are a little bit different. So that's my experience with replacing and programming modules. Like I said, I know other manufacturers may be a little bit different, but this is what I've had to do in the past. So you can use this and fill out that task sheet. Again, we were kind of pretending like we have a no start condition, which a module like this would cause. So our testing steps are going to be power ground communication, and then we've got some programming kind of stuff down here at the bottom. So use that to fill out that task sheet, and that is going to do it for today. Thanks.